Hello friends, welcome to our channel. In this series of basic process engineering calculations. In this session number 14, we will see uh, how to calculate the condensate pump, or we call it as PPPU pump, or pressure powered pump packaged unit, PPPU, sizing and its working animation. Okay. So before proceeding to sizing, we know that the in most of the industries, steam is used widely used as the main energy source or heating source. So that condensate carries up to 12% of total energy in the steam generated uh, and utilized. And without proper recovery mechanism, or we have to recover that condensate so that to avoid energy losses and in order to keep energy requirements to a minimum, it is important to that condensate is handled efficiently and energy from the condensate is recovered and it utilized for the heating or the in the boiler feed water tank for as a preheating. When it comes to the pumping the condensate collected, the centrifugal pump proves to be a highly limiting and costly, as the condensate is on high temperature, approx 80 to 90-95 degrees Celsius. So there is some limitations, and there are several manufacturer, they have design or specific pumps like foam Marshall or Spirex Sarco. Those are providing the condensate pump. Okay, so that pump can be used just approx 3 kg of steam per ton of condensate, and it can pump the condensate up to 100 degrees Celsius, or approximate 90-95 degrees Celsius to 100 degrees Celsius. Okay, so in this session we will first look how to calculate the sizing. So to calculate that we need some data, like we will input some data like steam pressure, what is our steam pressure available. Okay, so as per the IBR boilers in the plants, we have 9 bar gauge of steam. Then we have the condensate generated. Okay, how much condensate is generated from this boiler, that depends on the what is the actual consumption of your respective plants or the processes. Here I have taken one example so that you will get the better understanding how to calculate the uh, sizing. Okay, so here the temperature of condensate which I have taken is 95 degrees Celsius. Then the return header temperature pressure. Okay, because that requires to eliminate or overcome so that we can transfer the condensate. The static lift means what level we are lifting that condensate. Okay, so static lift from pump to the boiler feed tank. Okay, that is used in a feed tank to heat the water. So I can consider that as per the normal common practices or based on the practical experiences, there it is up to 8 to 9 meters. So I have considered here 8 meters, and we need 8 meters. So we need the distance from pump to the feed water, because we have utility section outside the plant or in the central utility section. So we have to mention that to calculate the pressure drop across the piping, that's it. So I have taken it's approx 120 meter. Now our first uh, step one, step one is to calculate the condensate, okay, volume, like how much quantity of condensate we are going to generate, and that needs to be transferred. So as we have already taken condensate generated here is 4800, so we have to mention density of condensate, okay, condensate at 95 degrees Celsius, okay. So at 95 degrees Celsius, the density of condensate is 960 kg per meter cube as per the standard data. You can get it from the Google also. Okay. So based on that, we calculate volume of condensate. At because we have that 4800 kg per hour is the mass flow rate. So we have to convert that into the volumetric flow rate, which is okay 5 meter cube per hour. So that can be converted to the liter per hour. To calculate that, we needs to convert that into liter, so that so we got the liter per minute, okay, as I have divided by 60. So we have converted that volumetric flow rate, metric flow rate of condensate, okay, for pumping. Now we got the volumetric flow rate of the condensate. So the our next agenda is to, okay, so here we have to calculate the pump sizing, okay. The next step is to select the pump model and sizing, okay. Now we have the data of the whatever the condensate flow rate. So based on that we can select the pump based on that volumetric flow rate. Here we have 100 liter per cycle, okay, liter, because we are requirement or our condensate generation is 84 liter per minute. So as per the standard models available, we can go with the 100 liter per cycle. uh, Considered 100 liter per cycle, that is the standard model available with the manufacturer. If you check with the another vendor, they have each vendor have their specific standard volumetric flow rate based on the models, okay. Here we have we need to calculate the required cycle per hour, okay, required cycle per hours, okay. That can be calculated by simply as we have the condensate load divided by we have selected the model from model cycle, okay, liters per cycle, okay. So based on that we have selected the pump model, and required cycle per hour is 48 numbers, Okay, we need 48 cycle per hour. Numbers or cycle per hour or cycle per hour. Okay, so now we have the required cycle details. So to transfer that condensate, we use air or steam as a motive media. So here I have considered the steam, motive steam pressure, because we need pressure of steam as well, because we are transferring pressure 7 to 8.5 bar g. Okay, we can consider the high pressure steam so that our transfer is happen within a short time period. Okay, so and if you check for the condensate load and the selected model approx the steam consumption of pump is. Okay, basically if you check for the each and every pump model, there is a specific requirement. Okay, so here the approx steam consumption we can check as average. It takes 5 to 6 kg of steam max for the per ton. So here we have 5 tons. So based on this model, I have kg. Okay, 35 kg per hour steam requirement to transfer that much amount of condensate. Okay, so now we have the condensate flow rate and the uh, its required cycles, and we have selected the model. The next step is to select the sizing. Okay, this step 3 is to steam condensate line sizing. Okay, so we have to decide then the line size of the steam condensate and the steam vent. All these are available in the pump. Okay, so we have to check the line sizing based on that. As in our earlier series we have explained how to calculate the line size. Okay, so as per available data, we go for the line size. Okay, diameter of condensate line. Okay, so we have calculated that for the 5-meter cube. Okay, so we can calculate that square root of 5 divided by pi by 4 into, we have considered velocity 1.5 meter per second into 3600. We are converting that velocity. Okay, so we got the line size in meter. Okay, so diameter of condensate line sizing for condensate inlet from plant to the pump. This is line size. So 34 is non-standard. So we have to take the standard line size is 40 NB or mm. Okay. So here we have the line size for the condensate, and the same we need to calculate the line sizing for the condensate transfer from pump to boiler feed water tank. Okay, feed water tank, which is one size higher to avoid or to reduce the friction factor or the frictional losses. So I think you got the question. What is the how to select the appropriate condensate sizing. So to size the condensate, as I have already explained here, how to calculate what are the data like the inlet motive pressure, back pressure, then vertical lift and pressure in return header or the any frictional losses. So based on that we can calculate the pump capacity and the line sizing and all these things. Okay, so I guess you got the clarity how to calculate the uh, pump flow rate and the sizing, line sizing. Okay, so here we can use the some automation or the like float walls, and all these are the assembly of the uh, pu- pump or pumping package unit. Okay, so here that unit consists of the isolation wall, NRV, then receiver and the flash vessel. Flash vessel generally used to calculate the to recover the steam and the condensate. Steam can be used for the low pressure steam applications, and condensate can be transferred to the boiler feed water tank. Okay, so now we will see the how Popo pump work and its working animation, so that you will get the better idea about this. So this is the Popo powered pressure powered pumping unit, and that consists of the receiver. This is the isolation wall, strainer, and body. Okay, body which contains the float mechanism, and this is the motive air inlet and the exhaust wall, and these both are the check walls. Okay, so air on steam are used as the motive media. Okay, the condensate receives from the plants to the flash vessel and get that transferred to the receiver. Also the condensate receive from the plants to the uh, pumping body, and that float float is the lowest position before startup. Then the steam and air inlet walls, the exhaust walls opens when the condensate flows by the gravity through the inlet to the check wall of the pump body. The float will become the buoyant, and it will rise. It will rise, the float continues, and to rise the mechanism linkage engaged, and which increases the tension on the spring. As the float rises up to its upper tripping position, the linkage mechanism snacks upwards center the energy of spring, and it pushes the rod towards the upwards, and simultaneously opens the motive steam walls and close the exhaust wall or vent wall. Steam flow increases the pressure inside this pump chamber, and then once the pressure gets more than the back pressure or the back pressure of condensate discharge line, it opens and that transfer the condensate to the feed water tank. Okay, as the condensate level in the pump body falls, the float is lowered, as you see in the animation, and mechanism linkage is engaged, which again increase the tension in the spring that pushes the rod towards downwards, and that open the exhaust or vent valves to release the some amount of steam flash available in the pump. This is the called the one pumping cycle, and it is closes the steam supply valve. As the pump body pressure gets lower, that opens the release the check valves, and the condensate freely flows from the again to the pump, and this is the complete the working cycle, and it is called as the one pumping cycle. So hope you got the clarity about what is the pressure powered pump packaged unit, and how to select the proper packaged pumping unit, and its basically working animation, how it works. Okay, still, please, if you like this video, please subscribe to our channel and press the like button, so that we come with the another new such interesting calculation which is useful for you. Thank you for now.